Okay, we're going to be talking about section 7.2 today, which is talking about applications of linear equations, which is basically solving equations, um, word problems. So we're going to be talking about translating words into symbols, so using different words to translate to figure out what the symbols mean or what symbols to use. We're going to be talking about applications. We're going to be talking about finding unknown quantities, mixture and interest problems, monetary or money problems, and motion problems. So first thing we need to look at is how to translate those words into symbols and some of the key words that you'll need to look for. So when you're looking at the word problems, you've got to read carefully to look for some key words such as sum, more than, plus, added to, increased by. These are all words that mean to add two things together. So when you're looking at these problems, you'll notice that basically the words are written down as we're reading them. So the 5 is written down, then the 8 is written down, the word plus is between the two of them, so plus is between those two. Some keys, if you see the word than in the problem, then that means that you're usually going to reverse the way that you have read it. So you'll notice that 3 is read first, but 3 is written down second in the problem. The number is first, the number is first. So these are some keys to look for when you're reading the problems. This is extremely important with subtraction. With the word less than, or words less than, you'll notice that, again, it's subtraction, but you have written down the 3 second instead of first. This is really important with subtraction because you cannot, subtracting two numbers is different depending on what order you write them down in. So it's extremely important, especially with subtraction, that you write them down in the correct order. With multiplication, some keywords are times and multiplied by. Another keyword is product. And the word of means multiplication. So keep that word in mind as you're going through and looking at some of the problems. Division would be quotient divided by. Ratio. Ratio is something we're going to be looking at some more of. Those are all things that mean to divide by. When we're looking at a word problem, if we look for the word is, I-S, in the word problem, you will usually be finding a word that represents the equal sign. So the word is represents the equal sign. So here's our steps. Step 1 is always to read the problem very carefully, try and determine what formulas you might need to use if necessary, what variables you might want to use, different things like that. What's unknown, what's missing. Assign a variable to represent that unknown. Usually, a lot of times people use X, but if you're not quite sure, you might want to use L or W, depending on what you're talking about, length or width. You might decide you want to use a table or something like that to help you solve the problems. And write the equation down using the variables that you've got. Solve that equation. And then step 5 is very, very important. Does it make sense? If you've got, 50 and 60 for your numbers and you end up with 5,000 for your answer, you might want to ask yourself, does that answer make sense? Is it reasonable, or did I do something wrong? And then check the answer in terms of the original problem to make sure it all works. So here's an example. A fenced-in area contains a total of 74 hens and roosters. If there are 24 more hens than roosters, find the number of each. So you've got to decide, what am I talking about here? We're talking about hens and roosters, right? Hens and roosters. And 74 represents how many total hens and roosters there are. So the hens plus the roosters is 74. There are 24 more hens than roosters. So here's a keyword then. So that means roosters has to be the unknown variable. So you can call it R or you can call it X. And the number of hens is based off of that. There are 24 more hens than roosters. So that's what we're talking about here. Step 1, we're trying to figure out how many hens and roosters there are in the yard. R is going to represent the number of roosters, and R plus 24 is going to represent the number of hens. And we know that the total number of hens plus the total number of roosters is 24. So this is roosters plus hens equals 74. And then we solve our problem and figure out what is the unknown variable. So we combine our like terms. R times R plus R is 2R. Here's our equal sign. Remember that barrier that we talked about earlier. So we got to subtract the 24 from both sides. So 2R equals 50. Divide both sides by 2. So R is 25. So the number of roosters is 25. So then if we plug that back in, the other equation was R plus 24. So if we plug in 25 for R plus the 24, that means there's 49. So that means there are 25 roosters and 49 hens in the yard. You can check your information and find out. 25 plus 49 is 74. There are 24 more hens than roosters, so all of these numbers make sense, so it is a reasonable answer. Here's another one. We have Bon Jovi and Bruce Springsteen, are two top grossing North American concert tours for 2008. And together, both tours generated $415.3 million in ticket sales. If Bruce took in $6.1 million less than Bon Jovi, how much did each tour generate? So our first step is that we're trying to figure out how much each of the tours generated. It talked about Bruce Springsteen took in 6.1 less than Bon Jovi. So Bon Jovi is my unknown. So I called it J for Jovi, and J is the amount for Bon Jovi, and Bruce is 6.1 million less than Bon Jovi, so it would be J minus 6.1. We know that both tours together, Bruce plus Bon Jovi, equaled 415.3 million. So now we're going to use that information to set up our equation. The Bon Jovi tour plus the Bruce tour equals 415.3 million. Combine our like terms. Now remember, I'm sort of skipping a step here. There's a 1 understood to be right here. And when I distribute that, these two things just come out, and I end up with J minus 6.1. So then I combine my J's together and get 2J minus 6.1. I add 6.1 to both sides because I'm crossing that barrier. And I divide both sides by 2. So Bon Jovi's tour made 210.7 million. So then substituting that back in, that means that Bruce Springsteen made 204.6 million. So Bon Jovi's tour generated 210.7 million in sales, and Bruce Springsteen's tour generated 204.6 million in sales. Now another way to get this number here would be to substitute it back in and say 210.7 minus 6.1, and that's another way to get the 204.6 million. All right, another type of problem are mixture problems or interest rate problems. Mixture problems, we're going to do a couple of those mixture problems. Mixtures are based on the idea that the base times the rate is the percentage. So whatever the base amount is times the percentage that you're dealing with is going to tell you what percentage of the mixture is that item. And then interest problems are based on the idea of principal times rate. So here we have an example of a mixture problem. A chemist plans to mix 10 liters of 40% acid with 70% mixture, but he wants a 50% solution. So we need to know how much 70% solution I have to add in order to bring my mixture up to a 50% solution of acid. Okay? So the first question we're saying is, how much 70% solution do I need to add? So X is going to represent how much of the 70% solution there is. So let's look at this diagram and look at it more. So I have two mixtures, a 40% mixture and a 70% mixture. I'm going to add those two mixtures together, and I'm going to end up with a 50% mixture. Okay, so I'm going to add the 40% mixture and the 70% mixture, and I'm going to end up with a 50% mixture. I have 10 liters, definitely. I have 10 liters of the 40% mixture. I don't know how many liters I need at the 70% mixture. That's what I'm trying to figure out. So the thing you've got to remember here is that when I mix these two mixtures together, I will have 10 plus X liters. Okay, so I had 10 liters of the 40%. I don't know how many of the 70% I have, but when I mix them together, I'm going to have 10 plus X, or 10 plus whatever I get. That's how many liters I have. These two mixtures are supposed to be equal, so that's what we're going to do. So 40% is 0.40 times the number of liters, that was the formula, base times percentage, equals 4. So 0.40 times 10 liters equals 4. 0.70 is the amount of the mixture I'm adding in. I don't know how many liters I'm adding there, so I get 0.70 times X. 0.50 is what I want. This is what I want to get. And I have 10 plus X liters, so I end up with this formula. Now I want these two pieces to be balanced. It's a balanced equation. So 0.40 times 10 plus 0.70 times X equals 0.5 times 10 plus X. So over here I have to distribute that 0.5, and I end up with 5 plus 0.5X. 0.4 times 10 is 4. 0.7 times X is 0.7X. Now at this point I need to combine like terms. Here's my equal sign, so remember that's my secret barrier. I need to subtract 0.5 from both sides, and that's where I get 0.2X. And I need to subtract 4 from both sides, and that's where I got the 1. At this point I want to divide both sides by 0.2. So 1 divided by 0.2 is 5. So that's telling me that I have to add 5 liters of the 70% solution in order to get the correct solution amount. So the chemist should use 5 liters of the 70% solution to get the right mixture. So to check ourselves, 5 times 0.7 plus 10 times 0.4 equals 7.5 liters. If I do the other part of the equation, I've got 5 plus 10 is the amount of liters I've got, times 0.5, which is 7.5 liters. So the problem does check out. I ended up with 7.5 liters for both of my problems. All right, let's do another one. A medicated first aid spray on the market is 78% alcohol. If the manufacturer has 50 liters of the spray containing 70% alcohol, how much pure alcohol does he have to add to make the mixture, the final mixture, 78%? So, and I made the note here that pure alcohol is 100% versus the 70% or 78%. So we're looking at how much 100% alcohol I need. So X is the number of liters of 100% alcohol. So here's our formula. I've got 50 liters of the 70%. I don't know how much 100% I need. That's what I'm trying to figure out. So it means I have 50 plus X liters in my new mixture, and my new mixture is supposed to be 78%. So if we look at this and set it up, we're going to do 0.7 times 50 liters plus, remember, move our decimal place 2 places to the left, so 1.00 times x equals, I'm going to write this a little bit differently, equals 0.78 times 50 plus x. And there's my equation that I'm going to have to use. So here's that equation that we just talked about. So 0.7 times 50 is 35. 1.00 times x is 1x. Over here I have to distribute. So 0.78 times 50 is 0.78x. Oh no, it's 39, excuse me. Plus 0.78 times x is 0.78x. We're going to subtract the 0.78 from both sides. And that's where I get 0.22x. And then we're going to subtract 35 from both sides. And that's where we get the 4. And then we're going to divide both sides by 0.22. And so we end up with x equals 18.181818. It repeats itself. So that's telling me that I need 18.18 liters of the 100% solution in order to get the right mixture. So then to check myself, I'm going to do 18.18 times 100% plus 50 liters times 70%, and that comes out to be 53.18. Then we're going to do the same thing with the other side, and we're going to do 18.18 plus the 50 liters, which is 68.18, times the 78% gives us 53.18 liters. So it does check out. All right, so let's look at some money problems or monetary denomination problems. Those are problems that involve, you know, how many quarters do I have if I have this much money, or how many nickels do I have, things like that. So the thing to keep in mind here is that you always have to think in terms of the monetary value. So that you have to think of the value of one coin and multiply it by how many coins you have. So quarters, for example, are 0.25, nickels are 0.05. So here we have an example. We have a bill totaling $5.65. The cashier received 25 coins that consisted of nickels and quarters. So they want to know how many of each type did you get. Okay, so we're looking for how many nickels and how many quarters. So what we have to do first of all is decide, and it doesn't matter how you decide it. We decided that x would be the number of nickels. I could have very easily said x is the number of quarters. It doesn't make any difference. But I said x was the number of nickels. So since I was given 25 coins to start with, the number of quarters is 25 minus x. So a nickel is worth 5 cents. So we're going to say 5 cents times the number of nickels is 0.05 x. And 25 cents, 0.25 times the number of quarters is 0.25 times 25 minus x. The number of coins that I have total is 25, which totals out to $5.65. So the number of nickels plus the number of quarters equals $5.65. I have to distribute over here on the right, so I end up with, there was a step done here. So let me just say this comes out to be 6.25. This comes out to be 0.25x. This is 5.65. And this is 0.05x. So one of the steps that sometimes people will take just to make things a little bit easier, but with the calculator it doesn't really matter, is the decision was made that instead of having these 2 decimal places all the way across, why don't we just multiply everything in the problem by 100? And when we multiply everything by 100, this becomes 5x, this becomes 625, this becomes 25x, and the last number becomes 565. That step is not required, but sometimes it makes it easier for people to work the problems out to have that information. So we're going to combine like terms. We're going to combine the 25x and the 5x. Since they don't cross the barrier, they're on the same side, we just combine them together and get negative 20x. Move the 625 to the other side, and we get negative 60. Divide both sides by 20, and we end up with x equals 3. And this is where you have to watch out for your negative signs. If you ended up with negative 3 for your final answer or something, that wouldn't make sense. So you'd have to go back and check your work. So that means that we have 3 nickels. And since there were a total of 25 coins, 3 nickels means that there has to be 25 minus 3 quarters. 25 minus 3 comes out to be 22 quarters. So the number of quarters times 0.25 is 5, and plus the number of nickels comes out to be $5.65. So it does check out correctly. All right, so let's look at some motion problems or distance equals rate times time problems. And what you have here are different ways that you can represent the distance formula. You can say distance equals rate times time. You can divide both sides by time and get rate equals distance divided by time. These are all just different ways of writing your formula. So let's look at an example. John can walk to work in 3/4 of an hour, but by bike, the trip only takes 1/4 of an hour. So if he bikes 5 miles per hour faster than he walks, how far is it to his workplace? So you've got to remember the 3 parts to the problem. Distance equals rate times time. So D is distance. So in this problem, that's what we're looking for. We're looking for how far. R is the rate, how fast we do something. 8 miles per hour faster is talking about the rate. T is time, 3/4 of an hour, 1/4 of an hour. Those are my time variables. So we're trying to figure out how far it is to his workplace. X is how fast he walks to work, and X plus 8 is how fast he bikes to work. Again, he bikes 8 miles per hour faster than he walks. So these two numbers here are talking about the rates. So looking at our formula, knowing it's distance equals rate times time, rate is x, time is 3/4, the distance equals rate times time equals distance. So rate times time is 3/4 times x. The rate for biking is x plus 8 because he bikes faster. The time is only 1/4 of an hour, so 1/4 times x plus 8. Now we know the distance to work is the same whether he bikes to work or walks to work. So we know that these two numbers here on the end are equal to each other. And that's what we've done here, is set them equal to each other. Okay, so again, we don't like dealing with fractions. So we're going to multiply both sides of the problem by my fraction to get rid of it. So common denominator is 4. So we're going to multiply both sides of the problem by 4. The 4's cancel out on the left, and we're left with 3x. And on the right, the 4's cancel out, and we're left with x plus 8. Finishing our solving, and we end up with x equals 4. Going back to our chart, x is the rate when we're walking. So that means that when he was walking 4 miles per hour. And therefore, when he is riding his bike, he's biking at 12 miles per hour. Okay, so again, this represents the rate. Oops, let me go back for a second. Did I say it wrong? No, I didn't. So this represents the rate. So the rate is 4 miles per hour. So 4 times 3/4 represents the distance. So the distance is 3 miles. So when we check ourselves now, 4 times 3/4 is 3 miles. That's what we got here for the first equation. So the biking rate would be 12 miles per hour. So 12 times 1/4, because that's how long it took, is also 3 miles. So it does check. Everything does check out correctly. Let's go back for a second. Let me refresh something, remind you of something. Remember that our question was, how far is it to the workplace? Everybody remember that? So when we got x equals 4, that does not represent how far it is. This represented how fast we walked. I want to know, how far is it to work? So I have to substitute in, and we substituted into this one and got 3 miles. The answer to the problem is the 3 miles. The answer to the problem is not 4. So just keep that in mind, that even though you got a solution of x equals 4, you did not finish the problem yet. All right, so let's look at another one. A train leaves Little Rock, Arkansas and travels north at 85 kilometers per hour. Another train leaves the same station at the same time and travels south at a rate of 95 kilometers per hour. And they want to know, how long will it take for them to be 315 kilometers apart? Okay, so we're looking for a time that the trains are traveling. We know that train N, I call it train N because he's going north, traveled 85 miles per hour, so this is his rate. Train S traveled 95 miles per hour, so that's his S. I'm sorry, that's his R. We don't know how long they traveled. We're looking for T, but we know that both trains combined traveled 315 kilometers. So train N's distance is 85T. Train S's distance is 95T, because remember our formula, distance equals rate times time. So train N's distance plus train T's distance is 315. So we set up our equation, combine like terms, divide both sides by 180. So I end up with 1.75, which is the equivalent of 1 hour and 45 minutes. So have we answered the question? The question again was, how long will it take for them to be that far apart? And the answer to that question is 1 hour and 45 minutes. All right, so I hope this helps. Again, keep up with your work. Let me know if you're having problems. Keep in touch with me about anything you're having problems with. And have a great week.